Okay. Hello, my name is Adam Hamšík, and thanks for inviting me here. Let's get to it. So I'm here for Labyrinth Labs. We are DevOps Cloud and Kubernetes partner. We help with our customers. Like we are mostly a Kubernetes shop, but we also help with migrations and stuff around that. So like with our customers, we are very well known for like not really working around and telling them how things are. So we have a no bullshit culture here, and that's really cool and really important for us. So uh, I'm used to be a DevOps engineer, but these days I'm going mostly to sales calls. So I really miss DevOps. So I at least go to meetups like these and talk. So I hope it's going to be useful for you. So I like to give you some overview what we are going to talk about. Like initially, we will talk about cost optimization as a topic. Like why is it important? Like why is it interesting for you? What to do? Then we will talk about like how we do it generally from top, like where we look, why is it hard, and where you can actually save money. And then we will go through really gore and technical details. If like we want to, we can skip that all the on the top and go to the technical details, but I think it's going to be useful for you generally from the beginning. So if you fall asleep after this slide, you can definitely take something from these presentations. So you have 4 bullet points which are really important to think about when you talk about or when you try to do FinOps and cost optimization in cloud. So first one is, if you want to save money, shut everything in your cloud down. You can shut down production and you will save most. So also, like optimal cloud costs are transitive property of good software architecture. That's a very good saying, and maybe like always think about it. Like, is this a good architecture? Because that's actually going to have some costs and also some impact on your cost or architecture. And very often when you talk to cloud vendors, they tell you that it's pay as you go. It's really nice. Like it's amazing. But also it's like a sword. It cuts both ways. So like pay as you go is nice because you can shut down things, but no one really does that, you know, as you probably know. And everyone starts new servers all the time. So there's also a pay as you go cost. And also like try avoid any shortcuts and try to do not to generate more technical debt, because that's going to have an impact later on. So why is cost optimization as a topic important for us? Like, do you know, like, do you have any metrics? Like reasoning that saying that my manager is always asking me why is it costing so much is not really an answer. But do you know how much generally companies overspend on cloud? Do you have an idea? That's one of the things. But for example, 3 of 10 companies don't really know how they spend their money on cloud. So like here are some stats. I can provide sources from them. It's not really made up. But generally, cloud spend is really growing over the years. And like no one really knows how they are spending their money. So that's why cost optimization as a topic is really important. Uh, for example, here, like right-sizing your infrastructure can generally cut costs by 36%. That's quite a lot. Like very often, if you say that you have a 10, 20, 30,000 a month bill, that's one third of that. That's a lot. Uh, very often when we talk to our customers, we always try to say that if you have really high costs, it's not really a like a disease, it's just a symptom. Like there is some reason for that. Like maybe generally you develop software in a bad way, or you make decisions in a bad way, but generally it's not a like a disease. So uh, like why actually cloud makes sense? Because like if it's too expensive and it's always easier to run things in on premise and it's cheaper, or like why we are using cloud. Uh, Generally, from my point of view, I think it's really nice to have lower time to market, uh, faster innovation. Those two things are really important to our clients and to us. We see a benefit from being able to deploy and be faster on the market. And also, very often when we dealt with on-premises infrastructure, like we had quite a lot of outages because someone wants to update NAS or storage and throws everything out, or switches and routers. Networking generally is pain in the ass. Yeah. And this is mostly the reason why everything doesn't work, because it's managers' fault. Okay, so how we look at the costs, and where we actually try to, how we look for possibilities how to reduce it. So first thing, as my colleague before me told you, like observability is a key. Like if you want to really understand where you are spending your money, you have to have a good observability. You also, experience really helps. Knowing that compute, storage, and outbound data transfer are two main cost drivers for every single cloud vendor is really important, because that would be three of things I would look first for every customer we have. Like how optimize your cloud compute is, how optimize how storage is, and how much do you spend on data transfer. But generally, like we always try to tell them, like don't really use reserved instances until you figure out if you can shut down your servers over time. That's really important, because otherwise, like you are running servers that just burn electricity and generate heat. Very often, like when we look at costs, we don't necessarily talk about like only the bill AWS send you or Google Cloud. It's also cost in people, outages, and like retraining people if you have really bad infrastructure, really bad software. It's a never-ending cycle. Like you develop software, then you figure out that you have too much technical debt, and your people are burned out. You have too many operations. Everything takes time, and then the costs are rising all the time. So cost per se is not necessary only by a bill. It's also by like your time, your people, and your effort. One of the interesting things about like cost is that one of the drivers from company side, not really application side, is technical debt. Like you can very often find out that companies are really neglecting their technical debt, or they don't really care. They make a lot of shortcuts over the years, and then they have a lot of outages, or like the applications are not really efficient and they are just burning money. So we always tell our clients to make sure that they understand what's there and how to maybe improve their application, and we're there too. And also, like, don't reinvent the wheel. Like, look for others, and look how to learn from others, and maybe reuse something everyone else already did. So observability is a really important metric, like where we try to figure out, when we try to figure out like how we are like spending our money. Like there are different ways how you can maybe do it, and how you like you can set up cost tags, you can set up like budgets, you can do this or that, you can use some managed platform for that. But it's always good to understand that being able to see your bill and parse the invoice your AWS or Google Cloud will send you is not necessarily the only thing you have to really have to do. You also have to being able to like measure and compare that to real metrics from your application. Like maybe I can like have higher latency on my application, but I will lose like 1/4 of the servers. Is that okay or is it not? Like being able to compare the real results to your SLAs and SLOs is really important. Like sometimes you maybe can figure out a way how do you use less servers and I don't know, don't really have any outages, but yeah, have higher latency or maybe use more asynchronous process setup. So this is a funny meme where like you are a young DevOps engineer and you have your first cost optimization project. Like you you look like this young Yoda, and then after it you look like a very old Yoda. So uh, like really doing cost optimization projects are really hard and demanding. So it's really demanding on your skills. You have to think about 1,000 um, different options, and it takes a lot of time and effort. So it's all as it goes with issues like this. It's always good to do them often. Like don't really do it once a year because that's crazy. Do them like once in a month, once in 3 months. Make them a habit. Like this is what we do every single quarter to make sure that we understand and we know what's going on. Also, it's really nice to show those metrics you are trying to follow to your developers, because once they understand them and they see that, okay, my application will cost our company this or that much, they will try to improve that. Like it's funny how easy it becomes when you present them with real metrics and real values. Before we did that, it was really hard to explain, like guys, like can you maybe change these and don't really generate 100,000 IOPSs on our database because it's not really import application. And they were like, oh, no, that's a real rework. But when we present them with a real value, they are really costing the company every single month. Like they were very happy to do so because their managers came to them and told them, like, guys, this is like this is really too much. So when we talk about cost optimization, when you already in cloud, very often, like AWS will tell you, like buy savings plan, reserve your database, and maybe use pod instances. That's basically it. And generally, for if you are a really big enterprise company, that's enough. But we always try to start here. Like you have to understand your workload. You have to look at it, understand what are the cost drivers of your workload, and maybe start there. If you refactor your application and make sure that it's mostly optimal, you can then reserve your instances, buy a savings plan, maybe use pod instances. That works very well. And you will get to a much lower bill than just buying reserved instances uh, and reserving database. And also, this is a continuous project. Like this will never end. Like this is not something you can plan into your sprint twice and then be done with that. Like you always have to do that. Like you always have in mind that, like, yeah, like what the cost is going to be, how can I improve it, like what is the driver here, and so on. Yeah, so as I said before, like it's really good if you have a good cost visibility and you can really provide accountability to your teams and to your developers, because otherwise they don't really have connection between money and their like application and their features. Yeah, like originally when I wrote this presentation, it was for one of our customers, and we put this here just to make sure that they don't really do lift and shift migration. So if your manager comes to you and asks you to do a lift and shift, for the love of God, run away. Like put your papers in and quit the job. That's really the worst thing you can do. Like you will never be successful there. Like you can migrate the servers in the meantime. Even that project will be late, and then it will cost your company 3 times more, 10 times more, and they will be angry at you, not at them. So make sure that you don't do lift and shift. Like re-architecture your applications, make sure that they work well in cloud, and then maybe like even if it takes more time, even if it's harder, like do it the right way. There is no shortcut here. Yeah, like I think we can skip this one. And yeah, so these are the technical details. And please, if you have any questions and everything, like ask. I'm very happy to have more sort of a discussion here. So one of the things we figured out, and I already told that, is that cloud costs are transitive property of good software architecture. And very often, where you can save money is introducing extra level of indirection and cache. Like you don't necessarily have to go to database for every single transaction. You don't necessarily have to serve every single request because it's cached on the client side or on the application server side. So make sure that you utilize this as a resource for you. Like memory and CPU is quite cheap compared to traffic, compared to database usage, compared to, I don't know, Kafka. So if you can, think about it, how to utilize cache, how to make sure that you really run well. Yeah, and yeah, avoid like the hype technical terms and for example, microservices. Like you don't necessarily need 100 microservices just because it's cool. Like because I don't know, Facebook and Netflix are doing it. It's not necessarily good for you. Like we have customers where they have like 6 members in a team, and they're running 60 microservices. Like you can imagine that it's very funny and really good for them. Yeah, like because we are in cloud native, then like look for Kubernetes. Like it's a very good way how you can actually make your workload scalable, make your workloads utilize your servers better and more. Don't be afraid of spot instances. Like very often when we talk to our clients, they generally told us, like, oh yeah, like we would like to use spot instances, but oh yeah, like they will, I don't know, die often and we will have outages. But that doesn't really happen. Like if you use Carpenter, if you set up your Kubernetes cluster well, it's going to be more or less fine. Like you will have some servers going down, but that also has some, I would call it a positive effects on your infrastructure. For example, with our clusters, we have one really big customer, and like uptime on our servers is mostly around like 2 days. Like we don't really have a server which is running for more than 2 days. And that's really nice because it removes quite a lot of issues and quite a lot of baggage you generally carry around like longer periods of time. Like sometimes things crash, sometimes your file system will fill up, or maybe your server becomes unresponsive. And by really rotating them and making sure that they die quite often, everything works fine, and it's not a problem for us. This also depends on your workload, so make sure you understand that. And here is a nice example how the cluster I was talking to you about looks like. This is the generic traffic, and these are the events or maybe even deployments. So we generally use blue-green deployments, so we really kick that off, and after a while it goes down. And here you have around, I don't know, 300 nodes, and the lower part here is around 70. So the cluster scales up and down quite a lot over the day, and it's quite good. So very often, uh, one of the shortcuts developers often do is use sticky sessions. I would like to use the same server every single time because whatever, and be aware of that. Like that's a really bad sign for you, for your application, and for your cost. Don't do that. Tell them that it's impossible and you cannot really do that in cloud, and make them remove that. Also, be aware of single points of failure. It's really nice that you can add new replicas to your pods and to your deployment. If you kill your database, that's not going to work. And from our experience, it's really nice if you split your application into smaller execution parts, and not really pods which are almost the size of the node are not really good scalable units. So better use more pods and with smaller resources than other way around. Also, we have clients where they have sort of event where before, they start an event at, I don't know, 8 o'clock, and 1955 there is no one, like there is almost zero traffic, and 2100 there is, I don't know, 10,000 users. So Kubernetes can handle that, but it will take time to pre-scale and to add nodes and to add to make sure that the workload works. So one of the things you can really do here is not really run it all the time, but make sure that you can pre-scale your infrastructure in a way that you will be ready for the event. Black Friday is one of the things you can probably get ready this way. And also, if you do it this way, you can always scale to zero if it's needed. Like you can remove the workload. So this is one of the statistics I pulled from the sources. Around 40% of instances are at least one size bigger than they need to be, and that's really quite a lot. When we do our setup, and when we tune our infrastructure, we try to utilize systems and servers to around 70 or 80% of temporary and memory utilization. That's sometimes, as you will see, not really working, but at least we try. We find out that it's always really important to load test our application. So we always, before we go to production, we always try to load test them to get better understanding of the behavior of application when it's running. And here is one simple node, which is running around 60% utilization. Yeah, we can go higher, but I wouldn't go higher than 70 or 75. After that, you can really experience some weirdness there. So one of the things which is really expensive in AWS, and we are mostly using AWS, so this is AWS related advice, is egress traffic. Even if you are using CloudFront, CloudFront is probably most expensive CDN you can find. It's quite expensive. So look for simple ways how you can avoid that. Like you can serve your data from Cloudflare, you can serve them from outside and not necessarily use AWS and egress traffic there. One of our clients that saved almost $20,000 per month just on egress traffic. And also, like good old compression is really nice. Like make sure you go and check if you are actually using it and if you are making sure your clients request the compressed files, because like that could be a really nice way how to save money with bigger scale. Cross-zone traffic is one of the ways how AWS really makes money, because that's something you cannot really investigate. It's really hard to solve, and they ask for quite a lot. So every single bill has like, I don't know, like the bigger bills are 10, 15,000 euros just on like cross-zone traffic. And one of the things you can do to make sure that if you are using Kubernetes, that it works well or it's better, is maybe you can look at topology-aware routing. That's a way and feature of Kubernetes where you can provide some hints, like this pod is running here or there, in this zone or that zone, and you can actually make sure that the communication goes through the same zone if there are any endpoints or not. You can utilize VPC endpoints. That's a good feature, and will save you money. And also, like you can keep workload in one zone if it's possible. One of the other things is NAT gateway. Like if you ever use AWS, you know that if you want to access internet from private zone or private network, you have to use NAT gateway. And AWS is introduced a thing called NAT gateway tax, like that's how we call it. And it means that there is quite a hefty price attached to actual NAT gateway usage. There are different open source solutions you can deploy and make sure that you don't necessarily pay for NAT gateway, and it works very well. So once you have quite a lot of traffic going out of your infrastructure, make sure that you look out alternate. And you can deploy it very easily, and it's going to save you quite a lot if you want to. So it's also good to understand like what your workload looks like. Can you run ARM or Graviton CPUs? That might be a good saving point. Also, like different instance types are more or less expensive than others. One thing which is really interesting is that R7 generation, like for example for databases or Elastic Cache instances, it's almost 20% more expensive than R6. So if you can save money, like use R6. Like it's the performance benefit there is very negligent. And AMD instances are almost like around 10% cheaper than Intel. So if you want and you want to support AMD, like you can use that too. I talked about that already, but the spot instances are a very nice way how you can save money and don't be really tied to any compute savings plans or to any reserved instances. And if your workload can work with that, like I definitely suggest to you to look at them and utilize them as much as possible. We have customers who run almost 100% of their workload on spot instances, and it works very well. It works quite nice with data analytics workloads where you span quite a lot of VMs and let them run, and maybe one or two will die, but you can finish the computation later. one of the things how you can actually save money in AWS is look at your databases. Like databases, from our experience, are quite expensive, and they are one of the more and bigger cost drivers in general bill you can find. Uh, AWS introduced a feature called IOPS Optimized Aurora Database or Aurora Instance, and very often it can save you quite a lot of money if you have heavy utilized databases. So if you have, look for that and try to use that and pay for it. They are generally more expensive than the standard one, but they are, because you don't really pay for IOPS, um, they can be cheaper. And here is the live example. This is the bill for cloud storage usage, cloud instance storage, instance and IOPSs, and the blue bars are like amount we pay daily for IOPS running through our database. And here is, once we switch to IOPS optimized databases, here is our bill after. So you can definitely see that the savings are quite meaningful. So quite a lot of our customers is running PHP, and over the years we more or less willingly became experts on like how to run your PHP application and make it perform better and save you money in cloud. One of the very nice examples was one of our customers' application, which was running just plain PHP FPM, and we over the years we came to them like, guys, maybe we can think about like different ways how to run your application. And one of the options you have in PHP world is a thing called Swool. That's nothing really breakthrough breathtaking, or there is no breakthrough here. It's just a persistently running application server, very similar to Spring Boot in Java. And once they ported their application to OpenSWOOL, we immediately saw that the application saved almost 70% of their compute uh, of needed replicas and their compute. But because we removed quite important and hard bottleneck there, one of the things we really quickly saw is that there is still some issue, because we knew we can make the application running faster, but it was still using quite a lot of resources. And when we started to trace and look at the application and maybe use Xdebug to see what's really going on each request, we find out that the application was using sort of a configuration files which were written in XML because it was quite old. And just moving from XML to JSON gave us 20% bump there, right there. Parsing XML is really, really hard and takes a lot of CPU resources. And then we try to cache the parsed results, and we get much better. Yeah, here is the graph. Like this is the original setup. This is how it looked when we moved to Swool. This is Swool without XML parsing, and this spike here is when we started to cache the results and not really going through file system and doing IOPS every single time. So we started here around 10, and we ended up around 60 requests per pod, which is quite an improvement. And this is how it looked like on our latency. The basic latency, the P99, this is the worst thing. was around 2 seconds. Like we've been able to improve it under 1 second in general. That's a quite good improvement. And like one of the things is that if you know your infrastructure and your application very well, you can start looking for different anomalies. Like this is something which takes quite a lot of experience, but when we were looking through this bill, we spotted one really important thing. Like there was quite a lot of throw zone traffic and the bill was really high. And then we tried to figure out like what's going on. And we find out that one of our applications, which was a smaller one, was using quite a lot of network traffic through database. And because this bug was there even before we migrated to cloud, no one really noticed that. Like the application was running this way for 15 years, 10 years, and it was just how it was. And if we look at that, like the application which was not really that heavy utilized was using almost like at the peak, it's 120 megabytes per second traffic to database. And we were trying to figure out like what's going on there. This is not really a big application anymore. There is not a lot of users. So we use our really good friends, TCP dump, strace, and PHP spy. Like these are your real good friends. Like no matter how good observability you have, like you will always use these two free comrades to help you with your job. And we find out that there is actually a problem. Like a developer forgot to add limit to a SQL query, and was for every single request the application received, he was executing I don't know 50 megabyte big query into a database and gathering the results and parsing them in PHP. And like the table where he was actually doing it never really was supposed to be that big. And once we find out that what's going on, he added a limit, and that was it. Like we saved a lot of money over the years then. And this is the number of nodes we had for this application. It was quite a lot before. It was almost 40, sometimes 50. And then we became, I would probably look for the minimum number of servers here is almost as big as maximum later after the fix. So also we not only save on the database, which could be smaller, we not only save on the network traffic, we also don't need that many servers as before. Yeah, and this one is the last, I promise. And sometimes good ideas leads to really big bills. And so we are using Thanos for our observability. And there is a like a service called Thanos Compactor. I'm not sure if you are familiar with that, but sometimes it will crash and die, and it cannot really run anymore. And no, and because Thanos works without compactor, it will not affect the service itself. We didn't really find out until 9 months later that it's not really running anymore. And we said, oh yeah, like it's definitely going to be useful. Like we should probably figure out what's wrong and start it up. And that was the good intent. Like we really meant good. But so we fixed the compactor, we started it, and then we always like for a month we look at it and said, oh yeah, it's working. It's definitely going to be good. And then we look at the bill, and then we spend almost 10K just compacting metrics no one really needs. So we could just drop them and be done with that, and there would be probably very little value lost there. But yeah, like we burned almost for 10K just on S3 requests and work done there. So that's all from me. Do you have any questions?